This video will be about light and albedo. So first, light. The sun emits a lot of light. Very little of it actually makes it to the Earth. Of the light that does make it to the Earth, about 40% of that light is infrared radiation or longer wavelengths, lower energy. About 50% of the sun's light that reaches Earth is visible light, and 10% of that light is ultraviolet radiation, X-ray, or gamma ray radiation. As you can see, the Earth receives a lot of visible and infrared light, so visible light and weaker. Now first, infrared. While visible light is pretty easy to wrap our minds around, infrared light is invisible to the naked eye. But all objects on Earth emit infrared light, including living things, as you can see in this image right here. So while we cannot see infrared with our eyes, other things can pick up infrared, like cameras or infrared cameras. So even plants will emit infrared radiation as well. In fact, as part of their photosynthesis process, plants will actually emit more long-wave infrared light than a dead plant would. And so you could actually use infrared light to tell whether a plant is healthy or unhealthy, whether it's undergoing photosynthesis or not. Now, not all light that actually makes it to the Earth will then make it to the surface of the Earth. So the 40%, 50%, and 10% is only at the very edge of Earth's atmosphere. Now, once that light goes through the Earth's atmosphere, a lot of it gets absorbed, blocked, or reflected. So first, let's take a look at what gets absorbed or reflected. Now, reflected, a lot of light is reflected based on just scattering out of the atmosphere or bouncing off of clouds. But blocked is a little bit different. Only specific elements and compounds will actually block only specific wavelengths of light. So we can see where the rainbow is right here is visible light. What blocks visible light? Water vapor, oxygen, and some visible light is scattered due to Rayleigh scattering. What blocks UV light? Mostly Rayleigh scattering, but also oxygen and ozone for higher energies of UV light. What blocks infrared light? Water vapor, carbon dioxide, a little bit of oxygen, methane, nitrous oxide. And there are other elements not listed here that block certain wavelengths as well in smaller amounts. Now, beyond infrared, certain wavelengths like microwaves and radio waves, some of them are also blocked by various gases in our atmosphere. You can see that water vapor has a huge effect on wavelengths between 70 and 20 nanometers. Now, albedo is almost like the opposite of... Now, albedo is a lot like the light being blocked by the air, but instead of being blocked by the air, it's the percentage of light that is reflected by a surface. Now, albedo is almost the opposite of what we just saw with light being blocked by the atmosphere. With albedo, it's the amount of light that is reflected by a solid surface or even a gas or a liquid. So for example, if you were to look up how much albedo is a various object, you would see the more albedo, the more light that object reflects. Let's go ahead and take a look. So a mirror, a perfect mirror, would have an albedo of 1, which would mean it would reflect 100% of all light at that specific wavelength. Now here's the thing. Not every object will have the same albedo for every wavelength of light. So for example, some type of wavelengths will pass perfectly through a window, but UV light will be blocked by them. Whereas a mirror might reflect visible light perfectly, but a different type of mirror may absorb UV light or absorb infrared light. So when we talk about albedo, not all wavelengths will hold up the same to each object. Some objects may reflect more light at different wavelengths, and some objects may reflect less. Here's just a general albedo for various sunlight, so mostly infrared and mostly visible light. We can see mirror is 1. Fresh snow, 80 to 90%, so 89% of the light that hits it will reflect off. We can see as far as man-made objects go, concrete is pretty reflective at 55%. Grass, for plants, grass tends to be lighter in color than something like a trees would be. So grass is about 0.25 or 25%. A forest might be about 15%, which is pretty equivalent to solar panels. You can see asphalt, 12% for worn asphalt. Fresh asphalt would be much closer to 0. And we can see down here at the bottom, ocean water, very non-reflective. At just 6% of the light that strikes the ocean will get reflected out. So the higher on this list they are, the more light they reflect. The lower on this list, the more light they absorb, and thus the warmer they will be. So if we look at the Earth overall, we can see that not everywhere on the Earth has the same albedo. If you were to look up online, what is the albedo of Earth, you might see 0.3 or 0.31, meaning that about 30% of all light that strikes Earth is reflected back into space. But here's the thing. It's not the same everywhere because not everywhere on Earth has the same amount of land and ocean. We can see that near the poles, like 70, 80, negative 90 for the south, positive 60, 70, 80, 90, have a lot more albedo. Why do the poles have more albedo? They tend to have more ice. And if we look, ice and snow are very reflective. They have very high albedos. If we look near the equators, we're a lot less likely to find snow between 50 north and 50 south. Also, there could be different levels of oceans, and oceans can absorb a lot of sunlight. So the poles tend to have a higher albedo, whereas near the equator tend to have a lower albedo. It does also vary based on how much land and how much ocean you have. The more land, the higher the albedo. The more ocean, the lower the albedo. So you can see why the northern hemisphere has a slightly higher albedo than the southern hemisphere, because the northern hemisphere has more land. Now, the albedo of the land also affects the local climate of that area. So for example, if you had a city that had a lot of dark asphalt, a lot of roads, maybe a lot of dark buildings, that city will tend to be warmer than the surrounding area that may have a lighter surface. Now this can also work the other way around. If the surrounding area is dark black volcanic rock and the city tends to have a lot of plants and concrete, you could have a heat, or instead of having a heat island effect, you could have a cool island effect. So it works both ways. Now, in some areas where there may be a forest nearby, maybe the city will be cooler, maybe the city be warmer. There are other factors as well. It's not just albedo for the heat island effect. Other factors may include air conditioning use, how many power plants or other heat creating things, various fires could heat up a city as well. So usually cities will be warmer. Usually to have a cool island effect, you need other factors as well. But albedo is one contributing factor to heat island effect of cities. So usually cities are darker than surrounding landscape. So usually cities will have more sunlight that is absorbed into the ground. Now, the last part of this video is, what is the albedo effect? So we worked our way all around to the beginning. The albedo effect on Earth means that 1/3 of all incoming solar radiation will be directly reflected back into space. The other 2/3, some other things can happen. They can be absorbed into the atmosphere, or they can be absorbed by the surface. But the albedo effect means that a lot of light that strikes the Earth never makes it to the surface. It gets reflected back in